orthogonal cutting and what is oblique cutting? Anyone? Can you give me some examples of pure orthogonal cutting in real life? Anyone? So before we understand that what is the difference between orthogonal cutting and oblique cutting, first we need to understand that what is orthogonal cutting and oblique cutting. Okay. So basically, an orthogonal cutting and an oblique cutting, whenever the forces which are generated in cutting operation, whenever these forces are in three-dimensional space, or whenever we get a three-dimensional force system, it is known as an oblique cutting. And whenever we get a two-dimensional force system, we get a orthogonal cutting, or we call it as an orthogonal cutting. Whenever the forces are there in two dimensions, we call it orthogonal cutting. And whenever the forces are in three dimensions, we call it as oblique cutting. Okay. Now I asked you that to give me some real life examples of orthogonal cutting. So can you just go back and just imagine or just recall the type of cutting or machining operations which you have seen in your life, where you think that the forces which are acting are two-dimensional in nature? And if you can recall, then you tell me that which forces are there, which are which machining operations are there, or which cutting operations are there, which makes use of, or in which orthogonal cutting is there. Anyone? No, not turning, Ganapati. Turning is an example of oblique cutting. Turning is an example of oblique cutting. We convert that oblique cutting into orthogonal cutting. Okay, we convert it. But generally, if you want to see any machining operation where, or any cutting operation where it is purely if it is orthogonal cutting, I will give you one example. Let us say that you are having a cylindrical pipe, something like this. This is what? Cylindrical pipe. This is a cylindrical pipe. Now, I ask someone of you to cut it into two parts. So what you will do? You will bring a saw, right? You will bring a saw. These are the teeth of the saw. Then what will you do? You will move this saw in these two directions. You will move this saw in these two directions, left and right direction. Okay. How many of you say that just by moving the saw, this is the saw. How many of you say that if you just move the saw in left and right direction, the cutting will take place? How many of you say that if I just move the saw, if I just bring the saw in contact with the workpiece, and if I move the saw left and right, then the cutting will take place? Say yes or no. Or anything else is required? Tell me. Why are you not responding today? What about angle? What angle? Okay, think that I am keeping it like this. think that I'm keeping it like this or like this, doesn't matter. Doesn't matter. Angle is also okay. We should apply force, sir. Very good. We should apply a downward force also. We should apply a downward force. At the same time, we should apply a left and right force. Then only cutting will take place. Then only cutting will take place. So basically here, in how many directions I'm applying force? Here the force is a purely two-dimensional type of force. Okay. The force is applied only in two dimensions, only two-dimensional force system it is. So this is the pure example of a orthogonal cutting. This is the pure example of a orthogonal cutting. Okay. Means practical example of orthogonal cutting. Okay. So now we will see that what our turning operation is. The turning operation of which we were discussing about for the past many classes. Let us see that what type of operation is our turning operation. So this is what surface? Machine surface. This is what surface? Atmospheric surface. Now I will draw the tool. Okay. Now I will be drawing the three axes. You already know what are all the different axes we have. One is the longitudinal axis. Okay. Another one is the transverse axis. And the third one is the Z axis. I'm calling these directions as X direction. This direction as Y direction. And this direction as Z direction. Okay, clear up to here? Everything is clear up to here? Say yes or no.
Yes, sir.
Okay, all right. Now I told you about few forces which will be acting at the machining zone. Okay, one force was the main cutting force. Okay, so this blue one is cutting force FC. The blue one is cutting force FC. One more force will be acting, which was the contact force. Right? We have discussed that we have one more force which is contact force. So one more force is the contact force. This is the contact force. So there will be two components of this contact force. One will be the component along x direction. Another one will be the component along y direction. So basically, this contact force is known as Ft, which is thrust force. And these two components are basically known as, which is feed force. Ff is the feed force. Okay. And this one, which is known as Fr, that is radial force. Feed force and radial force. Feed force and radial force. Is it clear up to this point? Just observe the diagram once. Observe the diagram. Observe the diagram. Clear? Up to this point, clear, everyone? Up to this point, clear? I want everyone to reply and tell me. Okay? Yes. Now you see what am I doing. Here, what is this plane? What is this plane? Tell me. What is this plane? Tell me. What is the name of this plane? Tell me. I'm asking some question. What is this plane? What is that plane? Tell me quick. Cutting plane. Very good. Pi C. Cutting plane. Sheikh is not there today. Not cutting. Yes, cutting plane. I thought you wrote cutting edge. Sheikh is not there today. Mr. Sheikh. and a plane perpendicular to the cutting plane. If I want to draw a plane which is perpendicular to this cutting plane, is which plane? Orthogonal plane. Good. So this plane is orthogonal plane. That plane is orthogonal plane. Now I will ask you one question, or I will draw one more diagram. I am drawing the top view of the tool. Same tool. I am drawing the top view. Okay. So this is my cutting edge. Okay. You see this diagram. You see this diagram, and you tell me, I'm showing you the top view. You tell me that what should be the name of this force, what should be the name of this force, and what should be the name of this force. Tell me. Can you tell me? Have you commented? Radial force and radial force. Both radial force. Sandeep, both radial force. You are giving the right answer, but yes, good. This one will be, this one will be what? Feed force. This one will be what? Radial force. And this one will be thrust force. Okay. All of you pay attention. Something important is coming. This angle is what? Can anyone tell me what is that angle? What angle it is? Comment and tell me. Psi. Psi, yes. not psi s, side cutting edge angle. So if this angle is psi s, this line and this line, consider them as parallel lines. So what is this angle? Tell me what will be that angle? Psi s. Good. Okay. Right. Correct. This is also psi s. This overall angle is 90 degrees. This overall angle is 90 degrees. This angle is 90 degrees. Then what will be this angle? That overall angle is 90 degrees. So what will be that angle? This angle? 90 minus psi s. Good. 90 minus psi s. Now, this overall angle is 90 degrees. This overall angle is 90 degrees. This angle you already know. What will be this angle? Psi s. Very good. This angle will be psi s. Clear? How did we came that as psi s? Directly ఇక్కడ psi s రాసి ఉంటుంటే మీకు అర్థం అయ్యేది కాదు. That how did we came to that angle? But now you understood that how we got that psi s. So now you tell me that ft what we can write? Cos psi s equal to ff. Can I write like this? Can I write like this? From here, ft cos psi s is equal to ff. This is the thrust force, right? This is the feed force. This is the angle. The same I can write like ft sine lambda equal to ff. Why? Because cos 90 minus psi s equal to just a minute. Yes. If I want to write it in terms of lambda, how much it will be? 90 minus psi s only. So cos 90 minus psi s is what? Sine lambda. Can I write it like that? Can I write it like that? Yes or no? In terms of principal cutting edge angle, I can write it like this. Say yes or no? Okay, good, very good. Now you tell me what will be fr? fr will be ft. सेम कैसे होगा यार संदीप? साइन होगा ना, psi s, और fr इक्वल टू ft cos lambda. How many of you have got this? How many of you have got this? Is it clear to everyone? How did I got this ft and fr? Everyone please tell me, did you got it? Very good. Very, very good. Good. Now I am asking you one very, very simple question. Very, very simple question, and you have to answer me that what am I doing is basically I'm trying to calculate the resultant. What I'm doing basically is I'm trying to calculate the resultant. So after I got the values of fr, ft and all, I'm writing the what I'm doing is I'm writing the resultant. So resultant, can I write Ft? So the resultant of Ft, can I write like Ff square plus Fr square? वेरी गुड यार संदीप, तुम तो बहुत ज्यादा पढ़ाई कर रहे हो यार। तुम पूरा आंसर आंसर दे रहे हो, क्या बात है। नेपाल जाके बहुत पढ़ाई लिखाई में तुम्हारा मन लगने लगा लगता है मेरे को। हम्म, इतना पढ़ाई कर रहे हो तुम। तो द रिजल्टेंट एफ टी इज इक्वल टू रूट ओवर एफ एफ स्क्वायर प्लस एफ आर स्क्वायर, राइट? कैन बी राइट लाइक दिस? कैन बी राइट लाइक दिस? आई गॉट एफ टी, I got ft. Can we write like this? Say yes or no. You want to see the diagram? You see the diagram. I can write the resultant like that, right? Now you tell me one thing. Now you tell me one thing. Now the resultant of cutting force and thrust force. Now the resultant of cutting force and thrust force. Now the resultant of cutting force and thrust force. All of you pay attention. Those who are not listening, they also listen. Okay, only this point you listen. Now the resultant of thrust force I got it, na? From feed force and radial force, I got the resultant of the thrust force. Now I want the overall resultant cutting force between the cutting force and the thrust force. So can I take the resultant like this? Can I take the resultant, the final resultant R? Can I take the final resultant R, which is root over fc square plus ft square? How many of you say yes? How many of you say no? Can I take the final resultant like this? Final resultant. Observe and tell me. Tejas is saying yes. Ashakaran is saying yes. Very good. Inka? Ganpati is also saying yes. Fantastic. Inka? Andro oksara yes and chepte. Appudu manu resultant find out cheddam. How many of you said yes? Antaman, only 3. So no one is saying no. Everyone is okay with this. Everyone is okay with this. Everyone is okay with this. Very good. Very good. Very good. Very good. See one thing here. Observe one thing. That here this z-axis is there. No? This is the red one is z-axis. The cutting line, the cutting force and the z-axis are not coinciding with one another. I have deliberately made that diagram in which there is a small offset between the cutting force and the z direction. And you can't take the resultant, between the force which is not inclined or which is not coinciding with the axis. Means if your force system lies between the z-axis and the orthogonal plane, if your force system lies in this plane, if your force system, just a minute. This was our resultant. Na? If your force system, all the forces, if they were lying in this plane only, which is the orthogonal plane in the z plane, and the forces kuda ee plane lo lie aitene, you can find the resultant as root over of fc square plus ft square. But here you see that there is a small problem. Problem is that the fc force, this fc force is getting offset with this z-axis by some angle. Is getting offset with the z-axis by some angle. So since it is not lying in the z plane, or it is not inclined or not coinciding with the z plane, then what is the problem? That you can't find the resultant. Here you see all the forces are in the same plane. So that's why what you have done, all the forces are in the same plane. That's why what you have done, you have easily calculated the resultant, that is ff square plus fr square is equal root over of ff square plus fr square equal to thrust force. Easily you can calculate. But in this particular case, you cannot do that. Why you cannot do that? Because one force is not acting within the plane. This is becoming a three-dimensional force system. This is becoming a three-dimensional force system. This is the two dimensions, and this force is acting in another dimension. So you can't apply that resultant formula here. So do you admit that what am I saying is right? In engineering mechanics also, you used to draw free body diagrams. In engineering mechanics also, you used to draw free body diagrams, right? So the free body diagrams are always drawn in one plane only. Have you drawn a three-dimensional free body diagram in mechanics? You always assume that the forces are acting in the same plane. Three-dimensional free body diagram draw cheyum, right? So in that free body diagram, when you can't draw in three dimensions, so that's why whenever you draw a free body diagram and assume that the forces are acting in one plane, then only you can use the force resultant formula, which is R is equal to F1 square plus F2 square root over of. So here also there is a problem in which one of the force is acting in either direction. Not either direction, little bit of offset is there. How many of you have got up to this? How many of you have got up to this? Quickly tell me, yes or no. This is the problem we are facing. Have you got it? Yes, yes, very good. Now can you tell me what will be this angle? Can anyone tell me if the cutting force is inclined with Z, is not coinciding with the Z direction, it is at some angle with the Z direction, then what is this angle? Can anyone tell me what is this angle? Any intelligent person of the class can tell me what is that angle. Observe and tell me. One hint I will give you is that the cutting edge is inclined backwards. If it is a reference plane, it is inclined backwards and there is some angle here. And whatever angle with the cutting plane is inclined, at the same angle, the cutting force is also deviating from the Z-axis. Right? The same force with which the cutting force is also deviating from the Z-axis. So at what angle the cutting edge is inclined backwards? What is that angle? What is that angle with which it will be inclining backwards? This angle. Anyone? If you forget tool signature, then how will we solve? What is this angle? Alpha O, not alpha O. Alpha O is in this direction. Orthogonal rake angle is in this direction. That is the other brother of alpha O, which is I, inclination angle. If you say ORS tool signature, that is inclination angle. If you say ASA tool signature, that is back rake angle. So if you make back rake angle 0 during the force analysis, if you assume that the tool doesn't have any back rake angle, and if you assume that back rake angle to be 0, then what will happen? This FC will get coincide with the Z direction. Right? This FC will get coincide with the Z direction. This FC will get coincide with the Z direction, and your forces will lie in a two-dimensional plane, and you can easily use the formulas of engineering mechanics, which is the resultant formula and all the other formulas. Easily you can apply them for force analysis and for determination and finding of the forces. Okay, so that is nothing but if you just assume that I equal to 0 or alpha back is equals to 0, then that is nothing but conversion of this oblique cutting into orthogonal cutting. Okay, orthogonal cutting law, we assume that I equals to 0 or alpha B equals to 0. Why? Because we see that there is an FC which is not inclining with the z direction, so we can't find the resultant. So when this ft comes in, when you assume this alpha inclination angle or back rake angle as 0, then this fc, what happens to this fc? This fc becomes like this. Okay, this fc becomes like this, and then you can easily calculate the resultant between the fc and ft. So in order to simplify the force analysis, we assume that inclination angle is 0, and when you assume inclination angle as 0, that is known as orthogonal cutting. That is known as orthogonal cutting. Is it okay up to here? Is it okay up to here? Say yes or no. Say yes or no. Not getting? Yes, no? Good. Very good. Very good. Yes, everyone got it. Very good. One last small concept, then we will end the class. See. This is the top view of the tool. Okay, this is the top view of the tool. This is my psi s angle. Psi s is side cutting edge angle. Side cutting edge angle. Okay. Now, what is this plane? Cutting plane. And what is this plane? Pi r plane. Pi orthogonal plane. Okay. And what is this plane? Cutting plane. Sorry, x plane. Pi x plane. And perpendicular to this, pi y plane. Is it clear up to this? Everyone know this? What is pi y plane? What is pi x plane? Everyone know about this? Yes. Now, for simplification purpose, to simplify the force analysis, for simplification purpose, what can I do? Just tell me, what can I do such that both the planes of ASA and ORS, both the planes of ASA and ORS becomes one. Means there is no differentiation between ASA and ORS. Means even if I take into account ORS, it will give me ASA, and even if I take ASA, it should give me ORS. What difference I should make to this diagram? Tell me. నేను ఈ diagram కి ఏం చేంజ్ చేయాలి such that my ASA and ORS tool signature both become same? They both should coincide. Both the planes should coincide with one another. Both the planes should coincide with one another. What difference or what diagram change I have to make? Quickly, you have to tell me. Quickly. Just observe one thing. If I make psi s equals to 0, If I make psi s equals to 0, if this angle becomes 0, then what will happen? That this cutting plane will coincide with the pi y plane, and alpha naught plane coincides with the pi x plane. Do you admit or not? Pi x and pi y, what they are? Pi x is longitudinal plane and pi y is the transverse plane. Already taught, Tejasvi. I have sent you few notes. You read every day. Yes, correct. Lambda is equal to 90, then ft is equal to and fr is equal to 0. Maybe sir, अरे तुम कहाँ से पढ़ के आ रहे हो भाई ये सब? हाँ, इस दूसरे को तो नहीं दिया हो अपना लॉगिन, इतना पढ़ाई कर रहे हो तुम. So others, did you got it? What we have done? So if you make psi s is equal to 0, then ASA tool signature and ORS tool signature both becomes the planes of ASA and ORS tool signature, they get coinciding with one another. Okay, so our diagram becomes something like this. Okay, so you have only, this is one plane, this is one plane. Okay, let us assume that initially which plane it was? Pi y plane. And pi c plane, since this angle have become 0, this pi c plane, which was red in color, this pi c plane will also align with this. Okay, so pi y plane and pi c plane both have now become same. Okay, similarly, this pi naught plane and pi x plane both will become same. Here, the red one is what? Pi naught plane. Okay, and pi x plane is the blue plane, is the pi x plane. Pi x plane also becomes same. So they both are lying in, they both are coinciding with one another. So this will make the force analysis even more simpler. Okay, so this is also pure orthogonal. Yes, మీరు ఎగ్జామ్లో మాత్రం ఈ డయాగ్రామ్ ఇంకా ఈ డయాగ్రామ్తో ఎక్స్ప్లెయిన్ చేయాలి. ఈ డయాగ్రామ్తో మీరు ఎక్స్ప్లెయిన్ చేయకపోయినా పర్వాలేదు, బట్ ఈ డయాగ్రామ్ మీరు ఎలాగైనా ఎక్స్ప్లెయిన్ చేయాలి. సో వాట్ ఈస్ ద కేస్ ఆఫ్ orthogonal cutting? If I want to convert oblique cutting to orthogonal cutting, what I have to do? Tell me quickly. Quickly tell me what I have to do. First thing is that I should be made 0. And the second thing is that psi s should be made 0. So if you do it, then your cutting will be converted from 3-dimensional to 2-dimensional. 2-dimensional cutting ki change అయిపోతుంది. Then you can easily do the force analysis. For the simplification purpose of the force analysis, we assume that the inclination angle is 0, so that the FC force vector should coincide with the z-axis, and we can easily use the resultant formulas of engineering mechanics. And we also assume that psi s equals to 0, so that all the planes of ASA and ORS should coincide with one another in order to simplify the force analysis in case of machining. That's it. Okay, so I hope you got it. How many of you have not understand? Frankly tell me. ఎంతమందికి అర్థం అవ్వలేదు? అందరికీ అర్థమైందా? ఒకసారి yes అని టైప్ చేయండి. If you have got it, comment with a yes. Good, very good. Okay. All right, thank you. 51 students are present. I have sent you one notes, na? One handwritten notes I have sent you. Have you received it? One handwritten notes. Okay.
Yes, sir.
So you keep studying that notes, okay, and study only those topics which I taught you. Don't study the topics which I haven't taught you, because that is actually the notes of someone from GATE ASC coaching. So in GATE ASC, topics are more. So he might have written all those topics, but all those topics are not there in your syllabus. So you only have to study those topics which I taught you in the class. నేను క్లాస్లో మీకు ఏవైతే చెప్పానో ఆ టాపిక్స్ మీరు చదవండి. అన్ని కూడా చదవద్దు, చదువుదాం మీకు యూజ్ అవ్వదు. సెమిస్టర్ ఎగ్జామ్కి యూజ్ అవ్వదు, ఎండ్ ఎగ్జామ్కి యూజ్ అవ్వచ్చు. ఎండ్ ఎగ్జామ్ అంటాను, కాంపిటేటివ్ ఎగ్జామ్కి యూజ్ అవ్వచ్చు. ఓకే, సో ఇంకేదైనా డౌట్స్ ఉంటే నన్ను అడగండి. యూ కెన్ లీవ్.